Good morning, ladies and gentlemen. My name is Mark Halliwell from Taggle Systems. We're a Sydney-based company that's involved in low-power wide-area communications. In fact, it's arguable to say we were the first company in Australia to be involved in low-power wide-area communications, having designed our own technology way back in 2007 and 8. The founders of the company were involved in the original commercialization of high-speed Wi-Fi as we know it in our mobile phones and tablets, so the company has a very strong background in radio communications. The original focus was on cattle tracking because one of the founders is a farmer. The idea was to develop a technology which would be low cost, battery operated, with a device that would fit on a cow's ear. And while that proved to be reasonably successful in terms of the technology, it was a bit of a challenge in terms of the cost of it and the willingness of cattle producers to pay for it. So it wasn't commercial. So in fact, what we did was we got involved in the water industry, where we've had tremendous success, particularly over the last 2 or 3 years. We now deliver something in the order of 1.7 billion data points to 32 water utilities around the country, collecting data every hour from about 135,000 sensors. The essence of what we do is we own, operate and maintain a communications network which is designed to collect small amounts of data from large numbers of devices spread across wide areas. In this slide here, you see the Taggle receiver network in the center there. Those receivers are very sensitive radio receivers. They can pick up hourly transmissions from upwards of 20,000 devices, and with a range that's arguably greater than 1,000 square kilometers, great coverage, particularly for rural areas where it's nice and flat. We use primarily 3 and 4G as backhaul, but we also use satellite, which makes it very suitable for remote areas. On the left-hand side, you can see lots of sensors. These sensors are devices for which we have manufactured transmitters. So we provide an end-to-end managed solution. That is to say, it's not just a matter of selling you the gear and saying, go ahead and install it and call us if you have a problem. We actively manage 24/7 the communications from your devices through our network so that we can deliver our data to you as part of a managed service level agreement. The data, once it's collected, is yours. You use it with whatever platform you wish, whether it's, well, it really doesn't matter. Oh, that one. Within the agricultural space, we've been involved in a number of different areas. These icons here represent some of them. The first one obviously was cattle tracking. One of the challenges there was with the weight of the tag. If you want to have a device that's going to last, say, 3 years on an animal, it needs to be less than 20 grams. Otherwise, you end up with necrosis, deadening of the skin around the ear. All of these challenges were overcome, but as I said earlier, we still haven't managed to break that commercial barrier yet. Calf alerts is another area where we've been active. These are devices that are inserted into pregnant cattle or cows. The device is transmitting all of the time, but while it's inside the cow, those transmissions can't be heard because the radio transmissions are being absorbed by the water in the body of the animal. Once it's expelled, shortly before calving, then we can hear it, then we can pinpoint where the animal is and get an idea of when the calving event might happen. The work to date has been somewhat patchy. Location has been down to about 100 meters. The success rate is about 80%. But research and development is continuing. We're working with both researchers and commercial organizations to further develop this technology. Around the country, walkover weighing is a big issue. There's lots of systems out there, those that have 3 and 4G communications on board. One of the challenges they have is that 3 and 4G, as we all know, is not available everywhere, particularly where you want it. And so the advent of low-power wide-area network technologies means that we'll be able to make this more widely available, so you can have your crushes wherever you want to have them. In terms of water management on farm, we've been working with farmers in Victoria, in the dairy area, to monitor on-farm water, resulting in the saving of lots of water across farm reticulations. Polypipe is the way to go on farms, but unfortunately, particularly in Victoria where you get a lot of frost, they become brittle, they crack, and water just leaks out all over the place. So by being able to meter this, monitor it on an ongoing basis, you can make major savings in terms of water. Weather stations, again in Victoria, working with the Birdship Cropping Group, We have weather stations dotted around their locality. Bringing in local weather data in real time helps them enormously at harvest time, where they can mobilize crews when they actually need them and not sort of pre-deploy them and then find, sorry guys, it's too humid, we can't harvest tonight, let's all go home. Getting towards the end, what I call high-resolution rainfall monitoring, working with the National Centre for Engineering and Agriculture at USQ, as well as some cotton growers in New South Wales. We're deploying low-cost rain gauges with low-cost battery-powered transmitters, which bring back this data and is then mapped on an area to give you rainfall variability information. This helps enormously in terms of conserving water which is used for irrigation. My last slide. The Internet of Things, as we're finding out today, has a huge amount of things to offer. You know, we're currently at what I would call a high point in the hype cycle, where there's lots of, yeah, we can do this, we can do that. But it's only now that we're starting to get to see real results. And over time, I expect that these will consolidate and we'll end up with a very informative type of business. Some of the challenges ahead, lack of industry standards, and that's not a criticism, that's just an evolution thing. Within the world of industrial automation over the last 30, 40 years, there has been an evolution of standards so that you can go to any plant around the world nowadays, plug in your device and you know it's going to work. It'll take some time for that to happen in agriculture. I'll move on to the last one, which is telco promises. They're a little bit late to the low power wide area network space. They make lots of promises. People will be distracted by it, but please bear in mind that you can't put a mobile phone tower for every little sensor. You need a dedicated network designed specifically for your particular application. You also have the challenge of the longevity of telco type technologies. They come, they go, you really don't matter, they move on. Thank you.